This lesson is on permutations and combinations. Permutations and combinations, they both fall up under a category of mathematics called combinatorics. That's a branch of mathematics that studies different possibilities for the arrangement of objects. So we want to start with the basic counting principle, which says that one event can be chosen if one event can be chosen p different ways and another event can be chosen q different ways. The two events can be chosen successively in p times q ways. When determining the number of ways that you can get a particular outcome and the order does matter, then you're looking at the number of permutations. Again, if you're trying to determine the number of arrangements of objects or items and the order does matter, you're looking at the number of permutations. So you need to start with the number of objects to choose from, and then how many of those objects you're actually going to choose. And then to calculate the number of permutations, it's n factorial divided by the quantity n minus r factorial. To determine the number of permutations whenever you have repeating items or objects, you use the following formula: n factorial, the number of objects you have to choose from, and then divided by p factorial times q factorial, where p and q represent the repeating objects or items. Combinations are similar to permutations, except in combinations, the order does not matter. So ABC, BAC, CBA, they're all counted as one combination of objects. To determine the number of combinations, given n number of objects or items, and you're choosing r, it's n factorial divided by the quantity n minus r factorial times r factorial. First example, we want to list all the ways we can write t, v, and w. So we can, whenever you're start with tvw, and then twv is another possible, vtw, vwt, wtv, wvt. Next, we want to determine how many, you want to evaluate these permutations. We have 8 to choose from, and we're choosing 4. That's another way of writing that is p of 8 comma 4. So n is 8, so 8 factorial divided by 8 minus 4 factorial. So 8 factorial divided by 4 factorial. Keep in mind, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 times factorial is 4 times 3 times 2 times 1. So I could actually simplify that, because the 4 times 3 times 2 times 1, those would cancel, leaving me with just 8 times 7 times 6 times 5. But if you want to go ahead and just use your calculator, you'd have 40,320 divided by 24, or 1,680 permutations. We want to determine how many different ways we can write how many different permutations for the word sleeplessly. So there are 11 letters in that word. So, and we have 3 S's, 3 L's, and 3 E's. So 11 factorial divided by 3 factorial times 3 factorial times 3 factorial. When we divide those, we get 184,800 permutations. Next, we want to determine evaluate the number of combinations whenever you have 21 objects to choose from and you choose 4. 21 factorial divided by 21 minus 4 factorial times 4 factorial. So 21 factorial divided by 17 factorial times 24. 4 factorial is 24. It's 5,985 combinations. All right, so you are setting the combination on a 3-digit lock. You want to use the numbers 1, 2, 3, but don't care about the order. So keep in mind, this problem is a little bit misleading because that last sentence says, but don't care about the order. So initially you would think that since you don't care about the order, it's automatically a combination. However, and the word combination is even in the problem. However, if let's say the code to open the lock is 1, 2, 3, so the order does matter for the code on the lock. If you entered the code 3, 2, 1, it's not going to unlock the lock. So the order does matter, therefore it is a permutation. Next, a group of 20 people are going to run a race. The top 7 finishers advance to the finals. Find the number of possibilities. So this is clearly a combination because it just says the top 7 finishers. It doesn't specify any order for those top 7. So we have 20 people to choose from, and we're going to choose 7. So 20 combination 7. 20 factorial divided by 20 minus 7 factorial times 7 factorial. And we get 77,520 combinations. And last example, Elisa and Marvin are planning trips to 11 countries this year. There are 13 countries they would like to visit. They're deciding which countries to skip. Now pay attention to that last sentence because we're not trying to determine how many different ways they can go to those countries. They're trying to determine, count the number of ways they can determine which countries to skip. So if there are 13 countries to choose from, and they're planning to visit 11 of those 13 countries, there's going to be 2 countries that are skipped. All right, and the order in this problem, it does not matter. So this is a combination also. Again, we have 13 countries to choose from, and 2 of those 13 countries are going to be skipped. So 13 factorial divided by 13 minus 2 factorial times 2 factorial gives us 78 different combinations.